Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. The last time we met, we learned how to clean continuous data. Over the next 3 videos, we're going to be doing some additional pre-processing. So this is more related to cleaning the data files before analysis. First, we'll clean some unreadable variable names, because if you remember, in the BRFSS codebook, some of the variables start with an underscore. And actually, R doesn't like variables that start with anything besides a letter. So before we can analyze those variables, we have to clean them up first. Next, we'll learn how to combine multiple years of data and attach identifying information. So, for example, if you were interested in looking at time trends or doing 2-year averages or however many year averages, you would want to combine multiple years of data. And then also, if you had a contract with your State Department of Health for some identifying information on your respondents, you would also need to know how to attach that data file to the main BRFSS survey data. So we'll learn how to do that as well. Finally, we'll learn how to reorder factor levels and set the reference value. So by default, when you have a variable with multiple factors, R organizes it alphabetically. But if you wanted to, maybe you had a certain order that you were interested in the factors, like for example, low, medium, and high. Those are not alphabetical by nature, so you would have to resort them manually. Right. And also, if you're doing something like a regression analysis, you would need to set your reference value, because I think R also picks the alphabetical one for the reference value, but anyway, you may need to do that manually if the one that R selects automatically is not the actual reference value that you're interested in. So let me start by opening a new R session. Let's set our Cranmere to the cloud, okay, and set our directory to my desktop folder called R for BRFSS. All right, and I already have the code written. So we will start by loading our packages, right? So today we're working with 2 packages, the Rio package and the tidyverse. So let's go ahead and load those in. All right, and so what I did before starting this video is I already downloaded the XPT files from the CDC webpage for 2015, 2016, and 2017. So I'll just quickly show you where those are. So let's start by CDC BRFSS 2017, since that's the data file we've been using so far in this tutorial series. So every year of data for BRFSS has a web page like this. So this is 2017 with the survey data information, and if you scroll down to data files, this would be the data file that you're interested in. 2017 BRFSS data SAS transport format. And so to download that, you click on it, you open it in the bottom of the screen, and it will open when it's ready. Again, this is a large data file, right? Over 450,000 observations. So sometimes it goes a little slow. It says it still has about a minute. So, okay, so while that's loading in, I just want to show you that the other years of BRFSS data have the same web page format. So you can download data from any year. So I also downloaded from 2016. This is the page for 2016. If you scroll down again, it's the same data file that you want to download. So 2016 BRFSS data, SAS transport format. And I did the same thing for 2015. So for this tutorial segment, we're just going to look over 3 years of data. And here it is again for 2015, the SAS transport format. And actually, I noticed this yesterday. Maybe the last time I checked was about a month ago, I guess, at the years of annual survey data. And if I'm recalling correctly, there used to be data through about 1980 something, but now I'm only seeing data through 2013. So I don't really know what happened, but as of today, it looks like you can only download from 2013. So that may or may not be resolved in the future. If you want earlier data, probably I would contact the CDC directly because I don't know where these data files went. But that's neither here nor there. Okay, so our file was downloaded, so we have to extract it by pressing extract all. Then you browse for whatever folder you want to download it to. So I'll just put it back into the R for BRFSS folder. Select folder, and then press extract. And I already have a file by that name in my R for BRFSS folder, so I'm not going to actually extract it, but that is how you download the file, right? So you would want to do that for every year of data that you're interested in if you're looking across multiple years. So I'll just close this out because I already have that data file there. And I don't think we need the internet anymore, so I'll close that as well. Now I'm going to read in my data files. So I have the 2015 XPT file, 2016 XPT file, and the 2017 XPT file. And we're using this function called import, which comes from the Rio package. And I'm setting these data files to the object name called LLCP20 whatever for the year. So LLCP is landline cell phone 2015, 16, 17. And we set the object using this assignment arrow. Right, this should look familiar. We've read our data in every time that we're using data in this tutorial series, so this is nothing new. Let's go ahead and paste that in. And this is also going to take a while because all of these data files are quite large. So we're just going to let that run. Something I wanted to talk about while this is loading is that, yeah, so I didn't want to close the internet yet. Let me bring you back to the CDC webpage because I wanted to take a look at the codebook while we're waiting for those to load. So CDC BRFSS 2017, just click on the first result for survey data and documentation. Under survey data information, let's open up the codebook. Yep. So as I said, some of the variable names start with an underscore. For example, state is one that starts with an underscore. A lot of calculated variables, so RF-BMI5, for example. A lot of calculated variables also start with an underscore. I think that's the way the CDC indicates some of the variables that are calculated, meaning that they asked a question about height and weight, and then the CDC calculated, in this case, adults who have body mass index greater than 25. And they calculated that based on the respondents' report on their individual height and weight. All right, so some variables have an underscore like this. But R doesn't like these underscores, right? It's hard for R to read these variable names in. So we're going to have to rename all of the variables, and what we'll do is put an X in front of the underscore, just so that that variable name starts with the letter rather than an underscore. Let's check on the progress of our files being imported. It's still running. It's still in 2016. Okay, good. It's on 2017, so we're almost there. Okay, and the other thing, the reason why I haven't taught you how to clean variable names before this is actually when you import the XPT file into R using the import function and then export it back out of R using the export function, whatever happens when you convert that file from an XPT file to a CSV, I'm not going to pretend like I know what happens, it just kind of magically, in the CSV file, all of the variable names that start with an underscore get an X put in front of them. So I don't know why that happens, but when you read in your exported CSV file back into R, the variable names already have an X in front of them. So it kind of cleans itself automatically. And that's fine and that's good, but when you convert the XPT file to a CSV file, some data is lost. And I'll show you that in just a second. So now all of our data files are read in. We can take a glimpse. glimpse LLCP 2015. And this is our data file. Let me maximize this screen for you. All right, so this is our data file. In 2015, we had 440,000 observations and 330 variables. Let's glimpse 2016. In 2016, we had 480,000 observations and 275 variables. And then in 2017, we had 450 observations and 358 variables. So obviously the number of observations varies by year based on the number of people that they were able to survey. But also year by year, sometimes the CDC asks a different set of questions. So the number of variables is different between survey years as well. So if you're trying to look at a specific variable over time, first you have to confirm that that question was asked over each of the survey years, because it could be that they asked that question in 2017, but not in 2016 or 2015. So you have to check on that first. Anyway, what I also wanted to show you is that if we look at the structure of, for example, LLCP 2017, we see that there's a lot of information here aside from just the responses, right? So in this data frame, this is from the XPT file, we also have this attribute information. All right, and so if you're going to use the attribute information, this data gets lost when you export the XPT file as a CSV file and then import that CSV file back in. That's the data that's lost, is this attribute information. So it may be preferable actually to import the XPT file and clean that data so that you're able to retain the attribute information. So that's why we're going to clean the variable names in R instead of just exporting and importing and letting the X attached to the beginning of the underscore variable names automatically. All right, so let's do that then. All right, we've glimpsed our data. Oh, and I also wanted to show you that, for example, the underscore state variable starts with an underscore. And so if we try to call in that column just to take a look at it, we see that we get an error. So R doesn't like variables that start with an underscore. All right, but if we wrap that variable in quotes, we do get we are able to call that variable into the R console. So sometimes wrapping the variable in quotes works, right? Sometimes that resolves the underscore problem. Oh, and then this is just an example of a variable that doesn't start with an underscore, and we can still call this variable into the console. So this is the F month. It can read it in. And then again, even if we do wrap it in quotes, it can still read it in. So for some functions, R can read in the variable name if you wrap it in quotes. But in other situations, for example, if you wanted to filter out the variable underscore state, where state equals 6 for California, obviously you won't be able to do that with just the underscore. So let's check on that. Right, unexpected input, this underscore. But even if we try to wrap this variable in quotes, it seems like it worked, right? We don't get an error message, but if we try to glimpse that filtered data set, so I called it state 6, we get our variable names, but actually we lose all of our observations. So I don't really know why it's like this, but if you wrap a variable name in quotes, when you're trying to use the filter function, you'll get all of your variables, but you'll lose all your observations, and that's just useless. So wrapping the variable name in quotes doesn't always work, which is why we need to clean it. So to clean those variable names, what we have to do is select the variable names that starts with quote underscore quote, right? So we are looking only for the variable names that start with an underscore. And we're going to set that command. So select from a data file the variable names that start with an underscore. We'll set that to an object called x underscore var17 for the x underscore variables from 2017. So let's copy that and just paste it in. And if we glimpse x underscore var17, we have our observations. So in 2017, there were 82 variables that started with an underscore. And you can see that they're here, right? And R denotes that by putting these backticks around the variable name. So yeah, 82. Now that we have that kind of subset of variable names that start with an underscore, what we want to do is find the column names of this x underscore var17, so those column names here, and we want to paste an x in front of the underscore. So we want it to be x, then the name of the variable, and we don't want there to be any separation between the x and the underscore. So we do separation equals quote quote. And you can put anything in the quote marks, like you could put a space, you could put, I don't know, some other character like 3, I don't know, it doesn't matter. But if you don't want there to be any separation between the x and the column name, you just put sep equals quote quote. No space, nothing in there. All right, so we want to rename the column names by pasting an x in front of the column name with no separation between the x and the variable name. So let's run that again. Copy and paste it in. And now if we glimpse at the column names of x underscore var17. Okay, so actually I don't need to glimpse because they're just column names. It's not actually a data file. But if I call the column names into the console, yeah, you see that now we have an x in front of everything. That's good. We were successful at pasting an x to the beginning of our column names. All right, but what we also need to do is now we have kind of two data files, right? We have our x underscore var17 with our cleaned up underscored variable names, right? So now we have x underscore variable. And we also have our original LLCP data file. But what we want to do is bind those two data files together so that we have our original file and the data file with the cleaned variable names. So to do that, we do cbind, which is column bind. So we're binding on the columns these two data files. So let's do that. And I'm just setting this to the object name called LLCP2017X. So copy and paste that in. And now we can glimpse LLCP2017X. And oops. Okay, so when we scroll up to take a look, we see that we still have all of our observations, but now we have additional variables, right? So I just bound together the first, like the original data file, and then the x underscore variable names data files. So we started with 358 and we added 82. So now we have 440 variables. And if we look, it retains the variables that are like surrounded by the backtick that start with the underscore. And then if we scroll down, we'll see that at the end of the glimpse, we have the variable names that we just cleaned. So now we have some duplicate columns, right? Because like the x underscore state variable is the same as the backtick underscore state backtick variable. So if you So anyway, so we have some duplicate columns, and when you're working on analysis later, what you would want to do is just select the columns that you're interested in, right? So anyway, now you have all of your variable names, and it's just up to you to decide which ones you want to keep for analysis later. And we can confirm that the variables that we just cleaned are the same as the variables that they're duplicated from. Or rather, is that what I want to say? So what we want to do is make sure that, for example, like the PSU is the primary sampling unit. So that's like the respondent's ID. So we want to make sure that the original _PSU variable has the same contents as the x_PSU variable, right? We want to make sure that our original unclean variable names are the same as our newly cleaned variable names. So to check that, what I want to do is look at this data file and look at the first 10 rows of this variable. So the first 10 observations of the PSU variable. So when we look at that, we actually get the output in scientific notation. So to remedy that and actually see what the actual respondent ID is, we set that value as an integer. So this is the same code, but wrapped in the as.integer function. So when we do, okay. So when we paste that into R, now when we convert that command to as.integer, we can see that, observations 1 through 10, they have this ending of 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, etc. So these are our respondent IDs, and we want to confirm that the respondent IDs for _PSU are the same as the respondent IDs for x_PSU, right? We want to make sure that the respondent IDs, that everything is the same between those two columns. So now we'll check the as.integer, the first 10 observations for x_PSU. And when we look at that, we see, in fact, that they are the same. So it looks like the two columns have different variable names, but it's the same variable, right? It's just a duplicate column with a different name. And we want to keep the variables that are named beginning with an X. So if you're not convinced by just the first 10 observations, we can also verify by looking at the column _PSU, which observations are equal to the observations in the column for x_PSU. And so when we run that, we get true for everything. So, it's not able to show us all 450 of the observations, but if you scrolled all the way through everything, you would see it's all true. So every _PSU is the same as its like sister x_PSU. So it's true. We can also ask which ones are true, which will give us the observation number. So yeah, so all of them are still true. Each observation is true that the _PSU equals the x_PSU. We can also see which ones are not true. Or rather, we can also ask R to tell us logically. So we're asking for a logical vector, right? True or false. Which _PSU are not equal to the x_PSU. And that's false for everything. So it's across all observations, it's false that _PSU does not equal x_PSU. And then finally, let's ask which ones don't equal each other. And we get back integer of 0. So none of the observations don't equal the other observations. So we have confirmed that our _PSU variable is the same as the x_PSU variable. All we did was clean that variable name to put an x in front of it. So moving forward, we can use x_PSU in our analysis, and R will be able to handle that. All right, and in the next couple of videos, we'll be looking at working over multiple years of data. So I just want to run the code that we just did over the 2015 and 2016 data files. So I'll just talk you through that and then run it quickly. Right, so first we want to select the variable names that start with an underscore. Then we're going to take those column names and paste an X in front of the column names, but not have any separation between them. No separation between the X and the underscore for that column name. Then we want to bind together the original data file and our X underscore variable name object, and then confirm that the first 10 observations are the same. Because as we just saw, when the first 10 observations are the same between the underscore PSU and the X underscore PSU, they were also the same across the whole data set. All right, so that's for 2015. We're going to do the exact same thing for 2016. So I will just copy all of this over. Okay, so when we look at the first 10 observations for underscore PSU and X underscore PSU for 2015 and 2016, we see that they're the same. So I'm pretty confident that all of the observations are correct between the underscore PSU and the X underscore PSU for the data files 2015, 2016, and 2017. So we have successfully cleaned our unreadable variable names. I'm going to stop the video right now, and then when we come back, we'll look at merging multiple years of data together. All right, so I will be back very quickly. See you soon. Bye.